I will now start with the physics portions that you require for your 11th. Okay. Now, physics portions in the 11th basically is in two parts. There is volume 1. There is volume 2. Okay. Then I expect you to maintain a notebook. Okay. Now, in the first 1 month, we are going to study units and dimensions. Units and dimensions. Second, we are going to study motion in 1 dimension. And then we are going to study motion in 2 dimension. Okay, so this is my target. I think from Friday you will be having 4-hour classes, which means that daily there will be physics, chemistry, maths, and another class. So by the end of this month, we should try to finish off these portions. Okay. What do you mean by finish off? When I say finish off, I mean that you should have read the NCERT textbook thoroughly. You should have done all the book back questions. Within another 7 or 8 days, we are also ready to give you our first set of books, especially not the full thing, but at least that part containing relevant to the chapters that are being taught to you. You will be getting those books, but that is not very important. But the important is that please go through the NCERT textbook thoroughly, and please try to make sure that you have understood all the book back questions which are there in NCERT. If you do this, it will be, this is expected. Everybody should do this. Whatever you are doing, everybody should do this. Okay. Then I will give you some worksheets. I will post some worksheets online. Now I will be expecting you to work out these worksheets. Now the difference in the 10th portion and 11th portion is especially, yeah. So I'm sure most of you must be looking at 11th and 12th not only as getting a degree, but also as a foundation for your future, whatever it is. And trust me, physics is a very, very, very important part of this foundation for your future. Okay. Now, physics is important because those of you who are ever going to go for the NEET exam will say that physics is difficult, so I am not scoring enough. Okay. And those of you who are going for the JEE exam will say that, sir, I'm able to do maths, I'm able to do chemistry, but I'm not able to do physics. But when you go for the main exam, you will see that you will get maximum score in physics. If you look at students who have scored 99 percentile this year in the first JEE mains, all of them have scored 99 percentile in physics. Okay, all of them. So, and there are some more who have scored 99 percentile in physics, but not scored enough in maths and not scored enough in chemistry. Okay. So physics is a subject which appears to be intimidating in the beginning, but it is a very friendly subject. You know, it is difficult, but easy to score. Yeah. You will all the time be scared of physics, but marks will come. Okay. So trust me and go by that logic. In fact, even in the JEE mains exam, students who scored 10 out of 25, that is who did 10 questions out of 25 have got 98 percentile plus. While to get a 98 percentile, you have to do 16 questions in maths and you have to do 14 questions in chemistry. So all that it indicates is that, you know, it is easier to score in physics than it is to score in other subjects. But people don't realize it because of fear. Okay. So each one of you has to work with your mind and overcome fear. So what do you mean by you have completed these chapters? Now, what I mean when I have said I have completed these chapters is each one of you should do at least 100 questions by yourself. You have to do 100 questions by yourself. If you have asked a doubt, that is not counted. Okay, so you have to reach this level. Now, some of you may have already reached this level because I am seeing some of you have asking me doubts about all these. So these chapters you have read in your lower classes. S is equal to ut plus half at squared. V squared minus u squared equals to as. Then again V is equal to U plus AT. Primarily it will be this. You have already read this before. So, but what you have not done is you have not solved numericals. 11th is different from 10th in numericals. In 10th, everything came from your book and book back, and you thought it is easy. But in 11th now it is not like that. So we are doing the book back questions to get familiarity, but in our exams we won't necessarily get from book back, we'll get from other sources, right? So we will have to spend a little bit more time in trying to put in effort there and working out on that part. Okay, so yeah, so this is basically what is I have to say. Now first thing is, what is physics? Okay, when did physics really come onto this world? First thing is, physics studies natural phenomena. Mankind started thinking, why should the sun rise in the east? Why should the sun set in the west? If the sun is setting in the west every day, how is it going back to the east when it is night time for us? So is the sun traveling around us, or is it that we are traveling around the sun? So how are we traveling? So always mankind had that particular doubt. So in fact, we had a earth-centric world. Before Galileo, we had an earth-centric world. After Galileo, he said, no, the earth is not the center, the sun is the center. In fact, he was executed because of that. So from time immemorial, people have been thinking about different aspects. Why is something sinking in water? Why is something not sinking in water? Okay, so basically in physics, we study natural phenomena. Anything that you think is natural phenomena, we study about it. Okay, now in this, the world kind of says or starts physics with Newton having seen an apple fall down. But it is not only Newton who saw the apple fall down, Aristotle also saw the apple fall down, Galileo also saw the apple fall down. In fact, they also discuss what happens when an apple falls down. So there were these people who were called philosophers. There were these people who were called philosophers who were giving philosophy and trying to explain the natural phenomenon which is taking place on earth. Our own Aryabhatta was a philosopher. Yeah, so there were numerous philosophers all over the world who had little bit more understanding than the rest of the world and who told the world how certain things can be done. Okay, then somewhere around the 13th century, 14th century, 15th century, mathematics developed. It initially developed with gambling, but slowly maths went into the other areas. And people started looking at equations. And these were mathematicians. So first we had philosophers. Now slowly these philosophers developed and we had mathematicians. And these mathematicians saw wonderful equations around them. And when they saw wonderful equations around them, they tried to explain the availability of that equation in natural world. And when they spoke about the availability, or when they spoke about the visibility of that equation in the natural world, that visibility was mostly in the form of physics. So you have to understand that 90% of the physicists who have discovered or invented any part of physics were primarily mathematicians. So Paul Dirac, there was a mathematician by the name Paul Dirac. So Paul Dirac was able to tell that there is a particle which is neutral inside the nucleus. But that happened in 1916. But James Chadwick discovered the neutron in 1932. That means from 1916, mathematicians knew that there is something here, but it took the physicists another 16 years to show to the world what that something is. So even before the presence of an electron, mathematicians knew that there is something called as an electron. And then in 1880, 1890, when they did the evacuated tube experiments, they were able to see an electron. Okay, so what I'm trying to tell you is that the way science has developed, it has developed with a significant amount of contribution from maths. And then you look at that maths and then see how you can explain the different things which are happening around you. Okay, so and this is where makes physics little difficult, more difficult than other subjects. This is not true with a mathematician. A mathematician is only bothered about the equation. He is not bothered about anything else. So if you have ax square plus bx plus c, ax square plus bx plus c, a mathematician is only bothered about this shape. So he is bothered about the solution. He is bothered about the graph. That's it, over. So solution, I have very simple, x is equal to minus b plus minus root over of b squared minus 4ac by 2a. Solution is over. But the moment I get into physics, now I have s is equal to ut plus half a t squared. Look, this looks like a t squared plus 2 ut minus 2s. And you see, this looks exactly like this. And now I start thinking, what happens? What happens when a is equal to 1? What happens when a is equal to 9.8? What happens when a is negative? So now see, a mathematician is not bothered about it. Mathematician says, what the hell, you just go apply it here. Whatever you get it, over. But now I am now thinking, if a is equal to 1, the body is moving. What happens if a is equal to 0? So if a is 0, the body is moving with a uniform velocity. If a is negative, body is retarding. If a is 9.8, the body is moving in gravity. So as a physicist, I don't have to tell you about these equations. I tell you that a body is falling freely under gravity. Now you have to first imagine a is 9.8. Then you have to imagine s is equal to ut plus half at squared, and then start working. I am not saying that physics is greater or bigger or what. All that I'm trying to tell you is, it is because of these practical aspects that physics appears to be little bit more difficult. Okay, it is little bit more difficult than maths and chemistry and biology. So please put in little bit more effort towards physics. Try to spend time. The more time you spend in the beginning, it becomes a good friend. And once it becomes a good friend, trust me, you will like it. So coming back, in physics, we study natural phenomenon. So it all starts with us trying to understand that Newton studied an apple falling down. So how did he study an apple falling down? So he would have taken something to the top and then he would have dropped it. There would have somebody down who will be making some measurement. So the moment you talk of any experiment, you have to understand measurement. Now, initially scientists said, my foot, I will take my foot, and that's how the feet came. Then some people use their hand span. Yeah, but everybody's foot is different. The length of everybody's foot is different. So if I tell you that, the dimension of the room where I am sitting right now is 20 or 30 or 50 of my feet, how will you ever be able to imagine what it is? So one, I have to make a measurement. Two, I have to make a standard measurement. Standard measurement means the measurement that I make, you should be able to replicate without difficulty. Yeah, you should be able to replicate it. Now, if you are replicating it, then there has to be a standard. So I have to have my standard. So what we learn in units and measurements is, first, we should have a standard way of measuring. Now, how many things are you going to measure? Are you going to measure length? Are you going to, here when you saw the apple falling down, are you going to measure length? Are you going to measure time? Are you going to measure velocity? Are you going to measure acceleration? Or is it enough if you just measure these two? So what are the things that you are going to measure? So we are going to have lot of quantities in physics. Say for example, in the apple falling down, I have length, I have time, I have velocity or speed, I have acceleration, and I am telling you that if I measure this and this, all these can be determined. So now we are talking about some basic things that you are going to measure. And with the help of these basic things, you can comment upon these quantities. Why? Because velocity is nothing but a distance traveled or displacement traveled by time. So velocity is a derived unit, is a derived quantity. So first, in physics, we have two types of quantities. Certain quantities which are called the fundamental quantities. Fundamental quantities. Then we have another type of quantities called derived quantities. Fundamental quantities are those quantities which don't depend on anything. These are the basic things that you have to measure. Now, scientists did not start science this way. Scientists did everything. Once they did everything, there were a lot of people who were inventing in Italy. Our own Leonardo da Vinci was one of the first so-called self-made engineers in this world. Okay, he was a biologist. He gave you the entire human skeletal system he could draw without really dissecting a body. So he told that if God has made the human being perfect, this is the way he should have made, including the skull. And later on, when they really found out the human skeletal system, they found it exactly matched with the way he thought it should be. And they say that Leonardo da Vinci would just go to the market and for hours together watch people walk, watch people lift things, watch people move their body, so that he got an understanding of the skeletal system by observing people move the limbs and understand. Okay, and from there he started, and then he was able to draw the human skull exact to the number of bones that it is. The difficulty with the skull is you don't know whether it is a single bone or whether it has many bones. Right? So that is the beauty of the person. Anyway, coming back, what I want to tell you is scientists did not start science by saying that there are fundamental quantities and derived quantities. Scientists did a lot of work. Then as they did a lot of work in the 1800s, now there was a lot of work happening in Britain, the current UK. There was a lot of work happening in Italy. There was a lot of work happening in France. There was a lot of work happening in the United States. There was a lot of work happening in Russia, Germany, and not to leave behind, even in India. Now, most educated people went from the Europe. So Britishers came to India, they got the books to India. Once they got the books to India, Indians started reading. So we read the same thing that the Britishers have done. But amongst them, there were differences. The Britishers had a different system called the FPS system, foot, pound, second system. Now, while in US, they started a new system called the metric system, where they had meters and they had meters, kilograms, and seconds. Yeah. So Leonardo da Vinci had his own system. So when people were studying things in a different way, it was getting very confusing. So you ask me, what is the height of the tree in front of your house? And I say it is 30. Now you are worried whether it is 30 meters, whether it is 30 feet or 30 kilometers. Of course, this is not possible, but then you are worried about these two. So I went to the Amazon and I see if I saw trees which were really 30 size. Now what was it? 30 feet, 30 meters, right? So there are trees which are 30 meters, which are even 100 meters. So, but they are not, it's still unbelievable right now, right? So there was lot of observation all over the world, and people were making their own inferences based on the units in which they were measuring in. So the scientific world said, okay, let's put an end to all that. Let's call for a conference. Let's call all the good scientists, leading scientists all over the world. And then let's sit down and then let's decide on each thing what to be done. So based on that convention which happened in Geneva, they came up with some fundamental quantities. Now these fundamental quantities are the basics. So these fundamental quantities are not known. Say for example, length. So till then the prevailing length was span of your hand. Then you have foot, the length of your foot. Now these two are not. Elbow was also there, one elbow. So you take from the fingertip to the elbow, one arm or something they used to call it. Okay, so now these were there, but understand that each person's thing is different, length is different. So now when you have to say that I want 1 foot, now world over people should understand what is the meaning of 1 foot. Or if I want 1 meter, world over they should understand what is the meaning of 1 meter. So they said length is a fundamental unit, and they defined 1 meter. And to tell the world and to make sure that they are clear, they kept a scale made up of palladium. Palladium is an element. They kept the scale in Geneva. There is a museum there. In that museum, they have kept this palladium scale, which they said is 1 meter. Now, different people gave reasons as to what is the length and how much we should fix it. So they fixed this length as 1 meter, and then they said that this 1 meter is equal to 100 centimeters. Now, what the rest of the world did is they went to that museum, bought a sample of that, and then they kept it in their country. So we have ISI. So if you go to the ISI, they will tell you what exactly 1 meter is. And they in turn have one of these palladium scales, which they got from Geneva, saying that, look, this is what is 1 meter. So this is the first fundamental unit or first fundamental physical quantity that we need to know. Okay, now there is no other way in which you can define length. So length is the distance between 2 points, which is equal to 1 meter if it corresponds to that distance between 2 points on that scale, which is there in Geneva. Now, every time you and me can't go there and then check. So now we trust the ISI, not only the ISI, then the ISI has put a place, there's a standard place in every town. Even in Trichy, we have one. In Coimbatore, you have one. In Chennai, you have one. In Mumbai, you have one. So there are places where now you can take a scale and say, can you please test and then tell me whether this is 1 meter? And they give you a certificate saying that this is 1 meter. And now if anybody comes and checks, you can show that certificate. Okay, so this is one length. Length is basically the distance between 2 points, or the shortest distance between 2 points A and B. It is measured in meters. This is the SI unit of length. Okay, there are other units like foot, there are other units like kilometers, there are miles, but we do not talk about all these things now. Mostly everything is expressed in terms of meters. In fact, when I was a student your age, I used to read a book called University Physics, which was a book out of UK. And in that book, everything was in FPS system. So I used to consider myself to be lucky using that book, because I could work very easily with the FPS system and the MKS system. Why? Because in that book, gravity was always 32. So it is 9.8 meters per second, or 32 feet per second squared. So I used to find myself, it was a good exercise for me, for my brain to start thinking, because sometimes I have to take 9.8, sometimes I have to take 32, and that makes a person sharper. Okay, so that is length. Next, the second fundamental unit is mass. Okay, and mass is measured in kilograms. Again, they have a stone in Geneva, which they said everybody agreed, and this is 1 kilogram. Now, further they said that 1 kilogram is equal to 1000 grams, and they came up with all kinds of conversion. The next fundamental unit is Kelvin. That is, I should have spoken about time first. I'm sorry about that. Let's talk about this. Temperature. So what they did is they came up with 7 quantities, and they said, if you guys understand these 7 quantities, first was length, then was mass, then was time, then was temperature, then was quantity of substance, mole, then was candela, the luminous intensity. The sun is shining bright. How bright is the sun? I have a candle. This candle is burning bright. How bright is it? So that luminous intensity is measured in candela. And then you have ampere, amount of current passing. So their aim, the convention which happened in Geneva, their aim was to have the minimum number of quantities. It was not the maximum number. So their aim was to have the minimum number of quantities, such that these minimum number of quantities would help you find out the rest of the quantities. Okay, so that is what they have done. So length is measured in meters. Then you have higher units. Mass is measured in kilograms. Then you have higher and lower units. Time is measured in seconds. Again, you have higher and lower units. Temperature is measured in Kelvin or degree centigrade or the Kelvin scale. Kelvin scale is basically 273 plus degree centigrade. Then mole, 1 mole of a substance is 6.023 into 10 power 23 particles. If you are talking about atoms, it will be 6.023 into 10 power 23 atoms. If you're talking about molecules, it will be 6.023 into 10 power 23 molecules. Ampere, ampere candela, I already told you. Ampere is the charge flowing per second, charge moving per second. That is rate of motion, rate of movement of charge. So this takes you to current and magnetism. This is what we will be working with mostly in the first year. Most of the quantities will have dimensions which are related to this, of course to temperature also and mole also, first 5. Candela, we will never talk about it. It is not in our syllabus, so we won't talk about luminous intensity. We won't go to that part of optics. Whole of second year, you will talk about amperes. So this is how we have. Okay. Now, these fundamental units or these fundamental quantities don't just have a figurative meaning. They have much more complicated influence on us. The complicated influence on us is that every physical quantity can be derived. So every other physical quantity can be derived from these fundamental quantities and can be written as a combination of these. I will explain what it is. Combination of these fundamental quantities in exactly one way. In exactly one way. That means suppose you take velocity. Velocity is equal to length by time. So I will say it is Lt power minus 1. And everywhere velocity will only be Lt power minus 1. You cannot express velocity in any other way using fundamental dimensions. I mean fundamental units. Okay, so wherever any other quantity that you can think of, acceleration. Acceleration is what? Velocity by time. So L by T divided by T. So that is equal to L by T squared. So that is equal to Lt power minus 2. So this is referred to as the dimensional formula. And the moral of the story is that any physical quantity that you take, it will have only one dimensional formula. So acceleration everywhere will have only one dimensional formula, that is Lt power minus 2. Okay, so there are no messages from you. So I am assuming you are able to understand what I am speaking. Okay, so what I am speaking is that look, there are 7 fundamental dimensions or fundamental quantities which have symbols like this. And every other quantity is a derived quantity. Every other quantity is a derived quantity, and that derived quantity can be expressed as a combination of fundamental quantities, which is unique, and that formula, that combination is unique. That combination is unique. That means there is only one way in which it can be written. Okay, and this combination is called the dimensional formula. And here you have the first law in physics, that whenever you add or subtract quantities, they should have the same dimensional formula. That means from 1 kilogram, you cannot reduce 1 second, because here and here the dimensions are different. And it is because of this that it is always important that we look at the units of a physical quantity, so that we know where it is being used, how it is being used, and we know whether it is being used sensibly or not. Okay, so are you able to understand the importance of dimensions? Are you able to understand the importance of units? Are you understanding that integral to measurement is units and dimensions? Okay, So can we make note of this? Can we make note of this? And any thoughts come to your mind? Okay. So all this is very simple stuff. You have learned this in your 9th standard. You might have learned this in your 8th standard also. This is little boring. For a little time it will be boring. After that it will start getting interesting. So every time we read about something in physics, we are also worried about its units, and we are also worried about its dimensions. Dimensions help us convert. Dimensions help us understand how to measure. For example, speed. Speed is equal to distance by time. So I have to make a length measurement. I have to make a time measurement. So it will tell me how I can do this. Force. Force is equal to mass into acceleration. So it has dimensions m, mass, acceleration is distance L, t power minus 2. So if I have to measure force, I have to measure mass and I have to measure some length and time. Then if you tell me that there is a unit of force called Newton and there is a unit of force called dyne, how do I convert from Newton to dyne and dyne to Newton? So this mlt power minus 2 will help me convert. So mass Newton is the MKS system. So here I have 1 kg. So that 1 kg here will be 1000 grams. Length is 1 meter. So that meter here will be 100 centimeters. Time here is seconds. Here also is seconds. And we have a product of m into L. So product of m into L. So 1 Newton will give me 10 to the power 5 dynes. Similarly, I have energy in terms of joule. I have energy in terms of erg. So now dimensions of energy is force into distance. So the dimensions of energy will become m L squared t power minus 2. So when I go here, this 1000 is pakka, no problem. Here it becomes square. So here it becomes a 10 power 4. Here also it is okay. Now these two are being multiplied. So 1 joule is equal to 10 power 7 ergs. Okay. Do you understand? Can you make some notes? Why there are no comments from you all? Is it that I am not audible, or is it that it has become too much and we don't? So are you all able to understand what I am saying? Okay, so I am assuming that you all are understanding what I am saying, and I hope this makes sense. So let's write down some notes. So every derived quantity will have one dimensional formula. Different physical quantities, excuse me, different physical quantities could have the same dimensional formula. Example, velocity, speed, work, energy. So all these have the same dimensional formula. Whenever we add or subtract quantities, they should have the same dimensional formula. So I cannot subtract seconds from kilograms and vice versa. In any equation involving several physical quantities, S is equal to ut plus half a t squared. So this is one term, this is one term, this is one term. So all these terms must have the same dimensional formula, L, L, L. So in any equation involving several physical quantities, the dimensional formula of each term should be the same. Okay, can you make notes? Friends, we will take approximately 1 month now. My request is to get a nice long size notebook and put there, heading there called units and dimensions. After that, the next heading that we will be putting is kinematics. So with this units and dimensions and kinematics, we want to complete that long size notebook. So we will put ourselves a target in the next 1 month, one long size notebook without leaving much space in between. We will write and write and write and finish it. And if you do it well, you would have learned a lot. And your learning depends only on how much you have written, how much you have worked. It doesn't depend upon your teacher. Okay. So still there are no messages from you all. So I hope you are able to understand what I am saying. Now I want to talk about little bit more about dimensions. Now the other day I told you that sine 30 degrees is 1 by 2. So here what I have is I have sine theta. So here sine is an operation. Log is an operation. Exponent is an operation. Okay. Whenever you have this kind of an operation, this kind of operation cannot be done on quantities which have dimensions. These operations cannot be performed on physical quantities which have dimensions. Okay, to give you an example, if a body is moving in simple harmonic motion, y is equal to a sine omega t. This is a formula. Please understand that sine cannot be done on anything which has a dimension. So what is the dimension of omega t? It is dimensionless. That means it is m power 0, l power 0, t power 0, all power zeros. So from here, what can you infer as the dimension of omega? Dimension of omega is t power minus 1. Dimension of omega is t power minus 1. Then what is sine omega t? It's a number. So what is the dimension of A? Same as the dimension of Y. Y is the displacement. So A should also be displacement. So dimension of A is equal to L. Dimensions of omega is t power minus 1. And these are constants. So this is the first use of dimensions. So a dimensional formula or dimensions helps me understand the nature of constants in physics. Newton found out that F force is proportional to mass. Newton found out that force is proportional to acceleration. Then Newton said force is equal to K into M into A. Then they found out that the dimensions of F and these are the same. So K is a dimensionless constant which was later on assumed to be 1. So they said F is equal to M into A. So understanding dimensions helps me understand formulas in physics. It helps me frame formulas in physics. Because in physics, I only do experiments, and based on experiments, I come up with laws. So can you make some notes? Still there are no messages, means you guys are understanding. Okay. Suppose I am making a statement. K is equal to A e power minus E activation by RT. Okay, K is equal to A e. Okay, this is a complex formula. Let's do simple things and then let's come up there. Sorry. So next question. I did some experiments and then I found out that velocity of a wave, suppose I take a string like this and tie it, and then I have a wave moving on it. The velocity of a wave is proportional to tension. Velocity of a wave is proportional to something called the mass per unit length. Now I am asking you, tell me what is the formula for velocity? Okay, so I say velocity is equal to some t per x into mu power y. Okay, now I understand that if there is any equation, the dimension on the left side must be equal to the dimension on the right side. So I say Lt power minus 1 is equal to tension power x into mu power y. You don't know now, but slowly you will learn that tension is a type of force. So I'll have mlt power minus 2 power x. This is mass per length. So ml power minus 1 power y. So this is equal to lt power minus 1. When I simplify this, I'll get m power x, l power x, t power minus 2x into m power y into l power minus y is equal to lt power minus 1. So this will give me m power x plus y into L power x minus y into t power minus 2x is equal to L t power minus 1. So from here I can say that x is equal to half, and once I say x is equal to half, I can find out that y is equal to x is equal to half and y is equal to minus half. When I substitute here, I'll get this. So from here, I'll get velocity is equal to root over of t by mu. So dimensions also helps me come up with formulas in physics. Dimensions helps you come up with formulas in physics. Okay, can you make some notes? So this style of working is expected from you now, immediately. Okay, so if you all have been able to work it out, I don't know why you guys have suddenly gone silent. There are absolutely no communication from you guys. Till then, all kinds of questions were coming. Now there is nothing. Okay, so fine. Okay, who's the host now? Ranjit, are you there? Who's hosting this class? Messages director varadilla students kekkuradhu. Okay. Sorry, okay. Okay, so now some messages have come. What are dimensions? So that is what dimensions are, those physical fundamental quantities which will help you find out everything else. They are the building blocks of every quantity in physics. So if you are talking about acceleration, what is acceleration made up of? So that is not the right question, but a similar question. What is acceleration made up of? So acceleration is made up of certain fundamental things, those 7 things. Okay, just as you make a house with bricks, the same way when you have physical quantities, we make them with fundamental dimensions. Yeah, PDF module I will send very soon. We are unable to connect to you. Now you are able to connect to me. Sir, can current be expressed as I? No, current cannot be expressed as I. They have said current, you should write it as A. Dimensionally, you should write it as A. Symbol is different. Dimensions are different. Dimensions are basically those fundamental. Okay, basically, I will be explaining this all over again, but I want you to think. What is erg? Erg is the unit of work. Okay, there is some problem, so they disabled me. Can you explain the last slide again? I will explain, no problem. Can this dimensional formula be written in any order? Yes, they can be written in any order, but if you write it in one way, it is good for you, so you will be able to get it. General acceptable order is MLTA. Okay, mostly 90% of the quantities, let me go there. 90% of the quantities that you learn in physics will have M, L, T, Kelvin, and Ampere. So usually they always write MLT, and this you write in any order, doesn't matter. Okay, going to the last slide. I've gone to the last slide. I'll explain again, but I want you to think for some time. Okay, you think for some time, whatever you have today. Again, I will explain to you the next class. It will take us little time, but once we understand it, it will be interesting. Okay, so we will continue to work again in the next class. Please write notes and try to read your notes. That is what is more important. Fine. Okay, good. Thank you.